All right, students, so in this video, I'm just going to show you where the quadratic formula comes from, how you can get it as a formula. And in the previous video, I showed you that it does work by plugging it in. In this video, I show you where it comes from. So slightly different angle on this video. And again, it's a little bit advanced. It won't be, this sort of thing will not be on the test, but it's good for you to see it happen. So what we start with is we start with our standard form, ax squared plus bx plus c. And what I'm going to do is I'm going to try to get x by itself. So I'm going to take away c from both sides, and I see negative c equals ax squared plus bx. And the tricky thing is I've got x showing up in two different spots right there. So what I'm going to do is try to get x all by itself. Factor out an a, leaving me with x squared plus b over ax. Notice that if you just did the distributive property, you'd have a times x squared and a times b over a, which is just b. So all I did was divided out an a. And in fact, I can divide both sides by a, and I'm getting closer to having x all by itself. Now I've got x squared plus b over ax. Now, we've practiced factoring a lot, and factoring is great, and it doesn't really make sense to factor when you don't know the actual numbers. Factoring all depends on what the actual numbers are. But I'm going to try to factor it anyway, and I'm going to factor it in a weird way. It's technically called completing the square, but it's a little bit of a weird idea. So what I'm going to do is I'm going to put an x squared right there, so I know it has to be x times x. And I'm going to split my other piece in half. So instead of writing b over a, I'm going to split it in half. B over 2a. B over 2a x. And that works to give me b over a, because b over 2a is half of b over a. So then I know that I need to have here a plus b over a, and here another plus b over a. But this gives me a little bit of a problem. And the problem is here I have b squared over a squared. And that's extra. So what I do is I do this little trick where I subtract b squared over a squared, because then I've accounted for this. If you look at these two pieces, they're the same, so they equal 0. And so here's where we're at now. I have negative c over a, and I have my factored version, x plus b over 2a times x plus b over 2a, because that's like your factored form, right? Your length multiplied by your width. But then I have my little extra bit that I had to work with, minus b squared over a squared. Now, I'm going to rewrite this in a different way. I promise you this is going somewhere. Notice that these two factors were the same. If two things are the same and they're being multiplied, then we can say that they're squared. Just like b squared over a squared means b times b and a times a. All of that work got the letter x into just one spot. So now I just need to do a little bit more algebra, reversing my operations, and then I can get x all by itself. So we're only a few steps away. So I'm going to add b squared over a squared to both sides. So now I have b squared over a squared minus c over a equals x plus b over 2a squared. Let's make this into a common denominator on the left side. The denominator needs an extra a so that I can have a squared. So now I'm looking at I see a small error. Excuse me. Let's go back and fix that. When I went back over to my, I see an error here on my parentheses. If I go back over to my parentheses, it should have said b over 2a times b over 2a. And that would give me b over 4a squared. So look back over here. I had a small error right here where I had only b over a on the outside. And down here, I needed it to be b over 2a. and 2 times 2 means I need to have a 4 right there. So I'm going to make sure I have the 4 right there. Sorry about that mistake. I'm going to carry that 4 over right here. Carry that 4 here, here, and here. And carry that 4 here as well, which means I need to multiply by another 4 on this. So sorry about that. So we needed the 4 as well as the a in there. That makes this left side now into a single fraction. I'll move my face out of the way. Makes the left side into a single fraction, b squared minus 4ac all over 4a squared. And we're so close to being done now. We only have 2 more steps. Let's square root both sides to deal with the x squared part. And when you take a square root, remember you have the positive and the negative answer. So now we have plus or minus square root of b squared minus 4ac over 4a squared equals x plus b over 2a. The last step then is subtracting b over 2a from both sides. And so I'm going to just erase a little bit to give myself some space to work with. I'm going to come back up here to the top left corner of the screen just to finish out the last little bit of simplification. So what you can see here now is that we have negative b over 2a plus or minus square root b squared minus 4ac over 4a squared equals x. And this looks almost, but not quite, like the quadratic formula. And the last step that we do to simplify it is noticing that the square root of 4 is 2, and the square root of a squared is a. So you actually have negative b over 2a plus or minus. Now the square root is just on the top of the fraction, and the bottom is 2a. So they have a common denominator, and you can finish up with the quadratic formula the way that you've seen it. Negative b plus or minus square root of b squared minus 4ac, all divided by 2a, and there it is. So while I was going through this process, what I did was I started with my standard form, and I just tried to get x by itself. I did this fancy factoring down here, where I made a small error, but then I fixed it. I had b over a, but I realized it needed to be b over 2a because we had cut it in half to match with the middle term here. After that, it's just solving by reversing operations from here on out, a little bit of simplification, and you end up with your quadratic formula. So there you go. Let me know if you have any questions. Thanks for watching.